Right, so this is my lecture on action lists. All right, so I'm Sean Middleditch. For those of you who have not seen me before, pretty sure most of you that are here today know who I am. So I've DigiPen RTIS Senior, a couple of the games I worked on listed here on the website. All right, so a lot of people are kind of asking me already, what exactly is an action list? All right. So you've already seen action lists in games without even having to program a game. All right there. That right there is a visual representation of an action list. For those of you who have not played The Sims or RTSs or one of the other dozens of genres of game that have these, you can basically give your character in the game a list of steps to do, and they'll execute them in order. All right? That's what these little icons up here represent, is what the sim is about to do. All right, so an action list is a list of actions. Yeah, all right, we're done. That's presentation. Explain it all right there. All right. So they're actually, the basic version of action lists actually aren't necessarily lists. They're actually more like a queue, a first in, first out queue. All right? So what it is you have a list of actions that you put them on this list, and then they're executed one after the other, where an action is something that can occur or happen in game. So each of these would be called in sequence. So if we had an action list with X, Y, and Z, the game would do whatever X is, and then it would do whatever Y is, and then it would do whatever Z is in order. So just quick visual representation here. I'm horrible at graphics, so I apologize for just how bad this is. But let's say we've got a guy in our game, and we want him to eat a meal. Right? So we're going to figure out what steps does it take for him to eat a meal. Well, first, he has to go get the ingredients. Then he's going to have to actually cook the ingredients to turn it into a meal. And then finally, he can eat the food. So if you don't have an action list, trying to figure out how to execute this list of actions gets a lot harder. Right? You can start building state machines or doing all kinds of ad hoc code. But if you just make these discrete little actions, put them in a list, and then let the game engine and the action list manager execute them one after the other, it just works. Nice and simple. And I did really goofy animations, and I'm sorry. There was an action list probably involved in doing those animations. All right, so an action is something that is executable. All right, so in a game, especially a real-time interactive simulation game, they can take more than one frame to execute. So what we do is each action will be implemented as a class that has a method called, for instance, update. And this update method will be called every single frame. And it's going to get called over and over again until it decides that the action is complete. So this right here is just some really, really simplistic C++ code. For those of you who like to see code to kind of explain this, if we have an action interface, it's just a basic class. It has a virtual method called update that you override, and that gets called every frame. And there's this Boolean called isFinished. All right? That's how we know when the action is done. So if we have an action, for example, like walk to location, like I want my AI agent to walk to that corner over there, I would create an action. The class would be called walk to. It would have the position it's going to. And then the update function would just move him a little bit closer and a little bit closer to that corner every single frame. And then when it detected that he was actually in that spot or close to it, it would set isFinished to true. And then the action would stop running. And then the engine would automatically know to go to the next action in the action list. And actually had code for that right there. It's amazing. So, yep, this obviously is not real useful code here, but get the gist of it. Update, are we there yet? If we are, finished. If not, move towards the position. And then an idea as to how you would use this action list. We have a class called an action list that just uses an STL standard queue. That's one way to do to keep a list of things like an action list here. And we just have a simple loop. So long as we have an action to execute, we update the very first action. And then if it's finished, we pop it. And you notice this is not a loop, right? This is just, it updates the first action and only the first action. Because we're not going to run the later actions until the first one is done. And this is just going to get called over and over again every frame. So the only loop involved in running the action list is the loop in your actual, your main game loop. All right. So this idea that I just presented here is really simplistic. Right? You can do one thing and then you can do another thing. And it gets basic jobs done, but it can't do really complex things. For example, if you wanted to have a character that can walk and turn at the same time, which can happen if you've got like a corner in a path. If the guy just kind of walks into the corner and then turns and then walks, it looks really bad. Right? That's not how we walk. That's not how your characters in the game should walk. You don't want that kind of stuff to happen. And you want your characters to kind of interact with the environment as they're looking around. You might have the guy walking along, and then you maybe want to have an action where he'll turn to look at something or wave to one of his friends as they pass them. You want to be able to do multiple things at the same time. Right. So you can almost consider this a synchronous or asynchronous action. That's just kind of computer terminology for those of you who are more comfortable with that kind of stuff. I would never really use that kind of terminology. I usually use blocking or non-blocking, where a blocking action is one that stops any other actions from running, and a non-blocking action is one that allows other actions to run. So the standard action list that I already presented to you has only blocking actions. Every action is implicitly blocking just by the way everything is structured. By allowing to mix these, we get the flexibility, and we can do really complex things by mixing which ones are blocking and which ones are non-blocking. So updating our action interface, all we've done is we've added an isBlocking Boolean. And this is now something we can configure actually at runtime as well. So we don't have just to say, for example, that walking is blocking and turning is non-blocking. We can decide that this walk action is going to be blocking and that walk action is non-blocking, but it's changing the flag at runtime. And then here's an updated walk to action, which it doesn't, you notice that the code is the exact same. The actual action and the logic in the action doesn't have to change for blocking and non-blocking. That's entirely a property of how the action is going to be interpreted by the action list itself. So one thing that's really changed here is in the constructor, we now pass the blocking flag from the user into the base class. There's no actual code change to the update function at all. And then implementing the actual loop now is a little bit trickier than it was before. For one is I don't use a queue at this point because queues are strictly a first in, first out. So you can only remove items at the very front of the queue. And now that we can have multiple things running at the same time, we might have two actions that are running in parallel. And the first action might take longer to finish. So the second action list might actually finish before the first one does. So we can't use a queue because we won't be able to remove the second action. So let's use a standard vector for this. So now the idea here is that we're just going to actually have a while loop now inside of our action list update. And it's going to stop only when it actually gets in, it's only going to stop after it runs an action that is set blocking. All right, so another bad graphic, maybe help you visualize this a bit here. We've got these two non-blocking actions called rotate and wave animation. So that might be some character that's sitting here doing this kind of thing. Right? And then we're going to have these walk to action and open the door, but these are blocking. So they're not going to start even running until these two non-blocking actions are done here. So the guy might sit here, rotate, wave, and he gets over here. Then your character might say, oh, I'm done, and walk out the door. So one of the things that can come in kind of handy is what we call a sync action. All right, so if we go back to this graphic here, there's actually a small error in this graphic that I did not notice until a little earlier today. The idea here was that it would rotate and wave, and then when those are done, it would walk to an open door. But that's not actually what's going to happen. So if we have rotate and wave animation set to be non-blocking, and we look at our loop that we put in before, the action list is going to run rotate, then it's going to run wave animation, then it's going to run walk to, and because walk to is blocking, it's going to stop. So it's going to be rotating and waving and walking at the same time, which wasn't the behavior we were trying to go for. So what we would like to do is try to put it some way of indicating in here that we've got these two non-blocking actions, but we want them to completely finish before we get to the walk to action. So the sync action is a way to do that. Do I have? I don't have that in here. All right. All right, so yeah, I should have got this slide in here. I'm sorry about that. So what we should like to add is a sync action right in the middle here. And the way the sync action works is the sync action will remove itself when there are no other actions before it. So we've got the rotate and the wave animation, and then if we insert the sync action right here, it's going to rotate, it's going to rotate and wave. This is moving around. And then when rotate is complete and wave is complete, the sync action that's going to be sitting right here that's blocking and stopping walk to from running will say, hey, there's no one in front of me anymore. Now I'm done. And now it gets removed. And now we go to the walk to action and everything works the way we want it to. And this, I believe, was supposed to be a slide on the sync. That is the wrong title. So this right here would be the sync action itself. So yeah, ignore that. If the action list I'm in, if the front guy is me, meaning there's no one else in the list before me, then I'm finished. Yeah. So, I did have a diagram. All right, so there it is. So there's a couple other things you can do to the basic action list that might help, make it a little bit more flexible. One thing you can do is give actions a built-in delay. So you might want to have a list of actions, but you might want it to do, you want your character to do one thing and then do another with, say, a 4-second delay in between. So you can build in a delay timer to every action. So whenever you create an action, you say, how long should I wait before I start running? Another option you could do is just create an action called a delay action that is kind of like the sync action. It just sits there, blocks, and doesn't do anything, but its condition would be wait until whatever timer has expired. You can do the same thing with a built-in way to finish. You can also add some utility functions. Is the action list empty? Is this action the first action, which will help with doing your sync action? You can also run some of the things like, has this action already run yet or not? This can actually come in really handy with things like a walk-to animation or a walk-to action. So let's say you want to walk from 2 locations. Like you want a character to walk from that spot over there to that spot there, and then walk over to the door. For your animation to work, you actually have to know where you started and where you ended to get your timing working kind of nice with certain kind of 2D implementations. So if you just did this the naive way, and you start here, and then you move over there, and then you move there, you're not going to know where you started for that second walk-to action. Because the walk-to action, when you created it, the guy was standing right here, right? So he's going to end up like walking over there, and then the animations are going to be funky as he goes towards the door. With the did already run flag, you can just say this action has not yet started running. So when he gets there, the first time update is called, you go, oh, this is the very first time I've been called. I'm going to take my current position as the starting position and now animate to the end position properly. All right. So that's all just the really basic stuff. And I mean, you can do some simple stuff with that, but that's not really we get into the powerful uses of ActionList. So what I like to use is a feature I called lanes. Normal people would just call it a bit mask. All right, so the blocking, non-blocking is limited. The sync action helps, but yeah, it's not very flexible. So what we do, the idea here, is that each action we have in our action list, we assign to a particular lane, where a lane might be something like the animation lane, or the movement lane, or the AI lane, for instance. In each lane, only one action can ever run during a single update loop. So if we have the animation lane, we have 3 actions in there for animate, let's say, 3 blocking actions, I should specify, in the animation lane, like say wave, pick something up, and jump. Only one of these will run, the first one on the list. But if we have other actions in the list, like say movement actions, because those aren't in the animation lane, they're going to keep running in parallel. This gives us a lot of flexibility, a lot more flexibility than just having a simple blocking or non-blocking flag. So yeah, and then the way this works is the action list keeps a cumulative bit mask. So each action that it runs, it takes the bits for its lanes, and it does a bitwise OR together. And you're going to get now a single integer that has in it 1 bit set for each lane that has currently run. You can then take that with the action you're about to execute and do a bitwise and you can see whether or not there are any overlap. Because if you do a bitwise and you have anything non-zero afterward, that means you've had overlap with your bits. And now you know that this action should not run because another action in the action list has already used that particular lane. All right, so updating a little bit more for some actual code here. We have lanes in the constructor. This is just an integer, just basic bitwise operations. So if you want to define your lanes, you just do that with the usual hexadecimal stuff, and assuming you've all done bitwise operations in your CS classes already. All right. So here, the titles are all not right on these at all. All right, so the action list, now the updated version of that. You see, if the action is blocking, we update this mask with a bitwise OR with the bit mask that is on the action. Right. And then we run the action, and if it's finished, remove it. And right here is where we check to see if the action we're about to run if anything on that lane has currently happened. Right? So if we have bit 1 set, for instance, and another action that had bit 1 set has already run, then mask is going to have bit 1 set. We get here, we're going to AND 1 with 1, which is going to give us 1. That is not 0, so this isn't going to run. All right, so I'm going to try to use some of my bad graphic skills to try to clarify this a bit more. All right. So we've got here our list of actions and a list of possible lanes. So movement, animation, and behavior. And we're going to create a number of actions that we were expecting our little guy in the screen to execute. So walk to is both movement and animation. Right? He's going to be moving around, and he's certainly walking and doing animation kind of stuff. Find path is just a movement action. It's all related to movement. It's not actually animating in a way. It's just a little behavior sitting there, and its sole purpose is to figure out what movement should be made. Investigate is purely a behavior. It doesn't actually do anything. It's more just the AI, say, thinking, for example. However, you know, it's not blocking. So this little empty circle here is supposed to signify the fact that even though it is on the behavior lane, it's not going to stop patrol. Because patrol's on behavior, whereas behavior is both movement and behavior. So what's going to happen? We'll go through the action list, and we're going to look at the first guy on here. All right. So the walk to runs is the first action. It's going to always run in any action list implementation. So now we look at find path, and we see that, wait a minute, the bit mask is showing that something with bit 1, movement, has already been set. Find path has bit 1, so we actually can't run find path. It's blocked. Walk to is going to make sure that it has to finish before find path is allowed to run. So now we get to the next one, which is investigate, because we didn't stop just because an action was blocked. And we see, well, none of the lanes that it is on have run yet, so it's allowed to go. However, we're not going to set the bit for bit 3 because it's a non-blocking action. Finally, we get to patrol. So patrol was not blocked by investigate because it was non-blocking, but it's still blocked by movement because only one action in a given lane can run. So there's a lot of ways we can improve on this. It's a really basic idea. One thing you can do is have 2 separate bit masks for what is blocking, or for what you will block and who you will be blocked by. This can come in handy in a few situations, not a whole lot, but if you run into the places where you're thinking, man, you know, I really want this action to run, but if it runs, then it's going to screw up what this other action is going to run, but I still need this action to get blocked by that action. You can now have this kind of duality where you can say this action will be blocked by this guy, but if it comes first, it won't block the other guy. So another feature that some people have used is called a hierarchical action list. So the idea here is that each game object normally has an action list, but you can put an action list inside of another action. So the idea here then is that the entire action list in that action will not run if that action is blocked, which is kind of a confusing way of putting that. So let's say you've got a really complex behavior action, right? And you've got, before that, you've got a stunned action. So your character just got stunned, and that action is blocking and doesn't let any other actions run, so all you can do is just stand there and not move at all. You know, this behavior might have a whole ton of actions. It might have like a whole bunch of decision-making actions, and it might have a bunch of animations, all that kind of stuff running. But just by blocking that one action, you've now caused that entire subtree of actions to not run. Likewise, if you destroy that action, if the behavior action is removed from the action list for any reason, all of its children just go with it automatically. It's a great way of managing things if you have a lot of really complex actions in your action list. I'm sure those titles are really bugging me. Are those confusing you guys? Because I keep seeing them and thinking we just went backward in my slides. Not sure what's up with that. All right. Google Docs. Amazing stuff. All right, so here we go. Hierarchical action. We've got, there's an action list inside of the action, and during the update, we just call my action list update. If then that child action list is empty, we can mark ourselves as finished. That's certainly one way to do it. You could also have this action have a bunch of other logic in it, so you don't just have to have just a child action list. You can have all kinds of complex, you know, whatever it is you need for your game to actually work. There's no reason to stick to just one possible way of doing things. So some more suggestions on ways you can use action lists, cool things you can do with them. So lanes are a neat feature that I like quite a bit, but if you don't want to do the whole bit mask stuff and all this multiple stuff, you know, multiple bits per action, you can simplify it down to have a single number. So in this way, you might say that this action is an animation action. This action is a behavior action. There's no way to be both at the same time. It's either one or the other. And then you can still use the bit mask to get the exact same action list update loop. And you just calculate your mask by taking the lane, which is now just a regular number, and calculating which bit is going to be set for that lane. So it's a nice simplification, and for most of your needs, this is probably going to just be a lot easier than the other way and do everything you're going to need it to. Another option is to do a different form of hierarchical action list. This is where each action has a pointer back to a parent action. So the idea here is, let's say we have an action like path to. So we want our character to do some animations and then find a path to a certain place on our map. And the path to action doesn't actually move the character. It's just going to create more actions, like walk to actions, that actually move it along the path that the path to action found. When it creates these move to actions, it can now record that there's a parent pointer. So we know that these, say, 3 walk to actions were created by this particular path to action. So if now that path to action gets canceled, let's say the AI decides that we don't want to move anymore, this path through that I created, just get rid of it. We can now automatically go through our action list and find all the actions created by that path to and destroy those as well. So it's a nice way of doing hierarchical action lists, but using a single action list, and it gives you some flexibility at the cost of some complexity. I actually personally usually just do it this way instead of doing the normal hierarchical way that I showed you. But again, this can be a little bit more complex to debug, so it's up to you to figure out which one works best. Another thing you can do is allow yourself to push actions into other parts of the list besides just the top of the list or the back of the list. For example, with a path to action, when you create these move to actions, you probably want to create them right before the path to action. So you don't want to say, whenever I add an action to this action list, add it to the back of the action list or add it to the front. You want to say, I'm creating an action and I want to insert this action in front of this other specific action or in front of myself or behind myself or possibly any other weird position you need to get the behavior you're looking for. So it's pretty easy to just add a couple other variant functions besides add action. You can push action back, push action front, push add action before, add action after. Pretty simple. Another thing you can do are events for when an action has become blocked or unblocked. So this right here is, let's say you've got an action that's running and it's not done yet, so it's going to keep running every frame, but then you just added a new action in front of it. So now that action is first in the action list, and that action is also blocking. So this action that was running just got blocked, and it's not going to get its update function called for possibly several seconds, for quite a while. There might be certain state that your action has to be aware of. So one thing you can do is just add a couple extra methods to your action class called blocked or unblocked. And the idea is if an action has already started running and there's now an action in front of it causing it to get blocked, you just call the blocked method on it. And that just lets it know that, hey, whatever you were doing, it might be a while before you get to finish it. So if you had any special state, save it, do whatever you have to do. And then unblocked is the opposite. If you just detected this action was blocked last update, but now it's not blocked, you can call unblock, and it can possibly need, it might need to restore its state, recalculate something because it has to assume that the state of your game has changed over the however many seconds it's been since the last time updated. And when you combine this with the idea of having the ability to push actions in any order in the list, this actually becomes really handy, because when you're pushing actions all over the place, you're going to end up with actions that get blocked and unblocked all the time, and a lot of your actions really do need that extra state management. So another option is that you can allow an action to be paused. The idea of this is that you just call the pause method on your action, and it basically just turns itself off, so it no longer gets updated. This can come in handy if you're using a behavior action. For instance, like you want to have you've got this behavior that sits there and it's supposed to wave and rotate like we were before, but it's never supposed to end. It doesn't have an expiration time, because you just want this guy to constantly wave and rotate around unless something else happens. You might then have your AI detect, oh, hey, well, I don't want him to wave right now, so go ahead and pause that, and then I'll unpause it later. And then you just have these extra methods in there as well, so that some actions might care when they get paused or unpaused to, again, save state, restore state afterward. One of the most important things you are absolutely going to need for any decent action list system is a message delivery to the actual individual actions themselves. So if you have messages in your game and you've got any significantly advanced functionality implemented in your action list, your action list is going to care about what's going on in the world. And your action list is going to have to poll the world over and over. It's the reason we have message systems. So just allowing an action to either register for a message if you have an observer-based system, or if you have one where every game object gets every message that happens, just make sure the game object passes those messages into the action list, and then the action list passes it into its individual actions. It's going to be really handy, especially for when you're doing AI in your action list, which I'll get to in a bit here. So now, one of the really cool things about action lists compared to some other features in your game is that action lists are actually really debuggable. It's pretty easy to look at the different bits of state in an action list. Right? So every action has state that is going to be imposed on it by the system, just by the very nature of what an action list does. You know if an action is blocked, you know if the action is blocking other actions, you know if the action has been paused if you have that feature, you know which lanes an action is in, you know its parent if you're using the parent pointer stuff, you know which position it is in the list, so if you've got 5 actions, you know it's the first, second, third. You know which action comes before it, which action comes after, all this stuff. It's just implicit in the structure. Then you also have the specialized state built into each action. So if, for example, walk to knows what its target position is when you're moving. There's also derived state. So if you got an action list and an action is blocked, someone is blocking it. Right? So that's not implicit necessarily in the data itself, but you can certainly look at the data structure and derive that information. If an action's been blocked, you just go up the list, find out which guy is blocking before it, same lane, and now you know who's blocking it. So if you're ever wondering why an action's not running, having that information can be really handy to figure out what action took priority. And then you can also have additional debugging state you add possibly just for the purpose of your debug output. You might want to have a timer that just tells you how long has this been action running, for instance. Can come in handy if your action doesn't normally have a timer involved. Right. So you can just kind of print out this information in like even a really ugly text format like this. There's no reason to get super fancy if you don't have to. But now say I've got this action list, and I can sit here and just immediately look at it. That I've got these 2 walk to actions, and then a pickup action. So the next number is supposed to be an idea of lanes, which if you're using bit masks, just printing it out as a hexadecimal number is one way to do it. If it helps you, you can also just print it out as a binary number, so you can directly see which lane each of these actions is in. We can also see state. We can see that the first walk to action is blocking, and then the next walk to action is blocked. We can also see in that state, using the derive state I was talking about, we can say the first to action, number 1, is blocking, and here are the actions that it is blocking. It is blocking number 2 and number 3 from running. This is really handy information to have if something isn't working right. You can now look and see exactly, oh, well, this action is one that's misbehaving and causing this other action not to run. Likewise, if you're just looking directly at action number 3, you can see, well, he's blocked. He's not supposed to be blocked. Why is he blocked? Well, he's blocked by number 1. All right, so now I can go and debug what's going on there without having to sit here and sort through the entire action list or step through it. This is really ugly, simple. You wouldn't usually have the boxes drawn around it. It works perfectly. We did this in a couple different games, and without this, I never would have been able to get the action list, the complex action behavior on the action list working. You can certainly get fancy. You can draw it out graphically if it helps you, but there's really no strong need for that. So now one of my favorite things about action lists is actually building AI with the action list. Right? We talk about things like a walk to action or a wave action. These are just things that a character in the game does. These are not things that a character in the game thinks. These are not reasons why characters do things. However, it is possible to build all of your AI into the action list or into actions in your action list itself without needing a whole separate system or a whole separate architecture for making decisions in your game. So the action list is often used for managing the actions that the AI chooses to do. Again, walk to, animations, things like that. And then there's often then a totally separate system like a finite state machine, which are just awful things to write any kind of even moderately complex behavior in. I know if you get online and you look at AI, that's all you hear about half the time is finite state machines. They have their place, but trying to build any significant behavior with just a finite state machine is a completely awful thing to do. And then on the other hand of finite state machines, there's these super advanced systems. You'll see things like goal planning, behavior trees, really complicated high power architecture for AI. That is actually, there can be quite successful. Behavior trees are pretty popular right now with especially first person shooters. You've got these very human-like characters that have to do all these like really crazy animations to feel like they're real people. But most games don't need that. The games you're working at DigiPen here are not realistic World War II shooters where you've got human-looking guys. Even out in the industry, I mean, the vast majority of games are either 2D or very characterized, artistically styled games where you can get away with much simpler animations and much simpler behaviors. And trying to use a more complicated structure for AI is just going to waste a lot of your time. So if we're building an AI, we've got some things that we want to solve and that we're going to need our action list to solve for us. We want a minimal amount of architecture to write. We want to waste as little time writing needless code. So being able to reuse the action list is pretty handy. We want to be able to easily build new AIs. For example, if you're using a finite state machine, you'll have to find that you've got this one state machine you've built for, say, enemy number 1. But now you want to build an enemy number 2, and you've got to build a whole new state machine. That's a lot of time that you got to waste, and even when like half the state machines are going to be the exact same, you can maybe do inheritance, or you can find ways to share some of the behavior, but it's clunky and it's difficult to work with. It's not good. You want good debugging tools. We've already gone over the debugging tools for action lists. They're actually quite powerful, quite easy to read, easy to grok, whereas the debugging tools for certain other AI architectures are very difficult. State machines are horrendous. Because while you can easily see what state I'm in, you cannot easily see what states I've been to unless you have this log, and it's a lot of information to parse to, and it's difficult to see why things are happening in a state machine unless you're stepping through the code or writing just really verbose amounts of information to see what's going on. And then we want things to be flexible, but only flexible enough. You can certainly just say script everything. I integrated Lua, right? So just the designer can now write all of his AI in Lua. Super flexible, right? Except that now you're writing tons of code in Lua and you're not actually giving them any architecture at all. You've gone too flexible. We want to give just enough structure to get what we need done without getting in our way. Right. So action lists, again, for ease of use, we already wrote an action list. So if we just reuse the action list, we don't have to write any extra architecture. Right? That one's done. We can compose actions or compose behaviors by having individual actions, where an action represents a thought process of the character rather than something the character does. The action list is debuggable, and any flexibility we need beyond the basic action list, we can get with all those cool features that I talked about a little while ago. So the behavior is just an action when I talk about behaviors in a behavioral composition. Behaviors, however, are never finished. Where a regular action might at some time set its is finished flag to true, the behavior will never do this. The behavior is always running, it is always thinking, it is always evaluating, it is always getting ready to do whatever it needs to do. There's a concept of an active behavior. The active behavior is blocking, meaning that any other behaviors further down in the action list will not get to run. And then we prioritize these behaviors by their importance and how we want the action, or how we want the behavior to actually play out. All right. So we've got here a simplified version of what we did in Subsonic and Sonar. All right. So at the top of the action list are the higher priority actions. At the bottom of the list are the lower priority actions. So at the very bottom is patrol, and above that is investigate sound, search player. So what's going to happen is when the action list runs every frame, it's going to start at the top, and it's going to check chase player. So chase player is its update function is going to run, and chase player is if I see the player, run after him. And if I see the player and I'm running after him, that means I'm active, so set myself as blocking. So if the player is currently visible, its update says I am blocking, and now I'm going to start chasing the player, which it's going to do by creating more actions on the action list. It's going to create a move to player action, move towards player, something like that. Because it's blocking, then search, investigate, and patrol would not actually run. It's just going to chase and do nothing else, which is exactly what we want. If it does not see the player, however, it's going to go through the list here. So search for player, for example, we might set its condition to be active, to be if we saw the player but have just lost him. So in that place, it's going to go, I saw the player right there, but he just went around that corner, I don't see him anymore, so I'm going to push an action to walk over to that corner where I just saw him. And set myself as blocking so that investigate sound and patrol doesn't run. And then if it gets to the position, as soon as it gets to position, it's done at that point. So what's going to happen is he's going to walk over to where he saw the player, and if he doesn't see the player, then search for player is done, and it's going to keep going through the list. But if it does see the player, then chase player is going to be reactive, because as soon as it sees the player, chase player turns on, and it's going to start running after the player again. So if it searches for player and it lost him, then it's just going to stand around by default, for example. And if it gets to investigate sound triggers whenever the message you just heard a sound gets to the entity. And we were talking about message delivery to actions. So if the action gets the message, you just heard a sound, it's going to take the position that it said the sound came from, it's going to set itself to blocking and push the action, go to that location. So if the guy is just standing there and none of the other actions are currently running, because nothing's happening, and all of a sudden he hears the sound, that kicks in and he goes over and walks to the sound, which if that happened to be the player, there's a good chance while walking over to it, he's going to see the player in the process. And then all of a sudden chase player kicks in and he starts running after the player. Or otherwise, he might get over there, there's nothing there, he gets to the sound, is done, and investigate sound turns off. And then there's patrol. So if none of the other three are running, the patrol action is just, it's got a list of points it wants them to go to, and it just pushes the move to actions to move there, then move there, then move there, and it just keeps doing that endlessly because it's the last behavior in the list. So what we've done now is we've created 4 independent behaviors that don't know anything about each other. Nowhere in here to search for player, say, when chase player is done. It just says if I had seen the player last time you asked me, but now I don't see the player, then it activates. Same thing for investigate sound. It doesn't have any dependency on each other. So let's say we wanted to create a guard that he's got headphones on, so he can't hear anything. So we can just sit here and take this exact same set of logic we've already written, but when we create this version of the enemy, we just remove this action from the list. We never put it in there. Without having to write any new code, we've just got a completely new behavior, a completely new type of enemy who behaves differently than the other enemy. And we can also do things where we can rearrange behaviors once you get more than 4 in here. You can have optional behaviors like this guard has a particular behavior like, this guy patrols, but this guy just spins around in place and is just looking left and right, looking to see what's around. You might have different priorities. You might have guards that will always try to run away before shooting, or other guards will try to run up and attack, and then only run away if other conditions. Just by reordering things and adding, removing action or behaviors to the action list, you get complete customization. So it's a quick description of what we just went over. So now, that's just more description about what we were just talking about. So yeah, when the player's lost, chase player deactivates, it's all just completely decoupled. So there's a lot of other things you can use action lists for besides just AI and animation. You can use them for graphics. They're actually a really cool trick is you create an action for any kind of effect you want to run in your scene. Like, so let's say you got a game where the earthquakes happen and the camera starts shaking. Or you've got a game where certain effects happen and it causes like the screen to go white from a flash grenade. Or you've got another one where, for example, you want to have the pulsing red when you get hurt. By just pushing these actions into an action list where the update and the behavior of the action is to modify the graphic state, you can easily manage all the animations and state changes for your graphics without having to code yet another system specifically to graphics. You just reuse the one action list you already wrote, and everything just works. Plus you get the debuggability. You can look through what your action list is doing, so the graphics is doing what you expected. You've got a way of figuring out what's going on. You can also use this for a game state manager. For example, a lot of people like to use a state machine for a game state manager. I personally cannot stand using a state machine for a game state manager. There's a lot of issues with that. There's a lot of bugs. But if you think of your game states now as an action that is on an action list, this all of a sudden gets a lot simpler. So when the game starts, it just pushes a bunch of actions on your game state list. It's going to push the main menu screen. It's going to push on the title screen. It's going to push on then like the DigiPen logo screen. And it's going to start running through these. So it's going to run the DigiPen logo screen, which is blocking. That waits 3 seconds, fades away. And then it gets to the title screen, which waits 3 seconds, fades away. And then it runs the title screen. And then when you click the button in your title screen to play game, it just pushes the play game's action onto the action list, which is just running every frame. And that's actually doing your main gameplay. Then you have a pause screen. When you hit the pause button in gameplay, it just pushes a pause menu action on your action list. And the neat thing about that, unlike a state machine now, is that when you're done being paused and you hit the unpause button, it just says, okay, that action is finished, it goes away. And the actual gameplay action hasn't gone away. You haven't lost any state. There's no weird problems with trying to figure out, well, am I starting the state or transitioning back into the state? That's all taken care of for you by the action list, especially when you add in those blocking and unblocking or pause and unpaused events we were talking about earlier. The same thing you can do now with an action list, unlike a state machine, is you can have multiple copies of the same screen, which can come in handy in certain cases if you have, for example, a inventory action. You want to have, and then containers, like you have a backpack in an RPG, and you can open up a chest that you've been carrying in your backpack. You create each of these as an action that is supposed to be a menu. So now, even though you've got a single action for in container, one for your backpack and one for the chest, you don't have to worry about, I've only got one state, how do I keep track of which container I'm in? You have 2 totally separate actions with the exact same logic, but different sets of data, and it's just all taken care of for you. There's no extra work in getting this up and running compared to trying to use a state machine. You can even, if you're really desperate, use an action list for a certain form of scripting. So I've actually done this before. I would not say it was the best way to solve most problems that scripting is used for, but there are certain things like triggers in a trap system in a game, for instance. You could just have it so if you have this trigger and then you walk over to it and it's supposed to be, you walk on it and you're carrying such and such item, it triggers, and you script it. And then you get this other puzzle later in your game where it's supposed to be like 3 buttons you got to hit in a row and then a lever, and that'll open a door. With an action list, you can actually just have these action lists attached to these items, where every time the player performs a certain action, one of these actions will set itself to is finished, or to set itself to unblocking. So you got these 4 actions for this puzzle, this trap, and the first one is pushes button 1. The second one is pushes button 2. The third one is pushes button 3. Because these actions are blocking this order, you push button 1, the first action goes unblocking, and now only will the second action be able to receive the event for push button 2. And then if you push all these buttons in order, then the door finally opens. It can be easier because now you can build really nice drag and drop GUIs for the simple cases You want to build a trap, you just drag this button, drag this button, drag this button, or drag this plate on here, and then you drag the a condition on there, and you're done. This only works for very, very simple cases. As soon as you want like weird conditionals or branching, this completely falls apart. This is best used if you are literally at the last minute needing something up and running, or you are very sure what you're doing. You probably will want a real scripting language. You might even be just implementing your action list in your scripting language in those cases. And that's all I got. So, any questions? All right.
For the game state manager?
Yep.
Where would it be located? Would you put it in game logic or?
Yeah, just be in your main engine. So basically, your main. The question is, for a game state manager, where would the action list be located? So if you got like your main object, your main loop, you just have your action list there, and it just gets called update. Gets its update called every time through the loop. Any other questions?
More of a comment. More of a comment. Remember, you can just create your base action and action list and just drive for different purposes.
Yeah. So what Sean is saying is that you might have different types of base actions. For example, if you have an action list for graphics and an action list for behavior, even though they're the exact same action list class and you're using all the same infrastructure, you might have two different versions of the action class that derive from action. You might have a game object action versus a graphics action. The advantage here is if you're doing something any action that is meant to modify an actual character in your game probably needs a pointer or a reference to the character it's working on. So it's just handy to have for example, a game object action that always has that pointer in there. And then your actions that actually use that can be walked to derives from game object action instead of deriving directly from action. So, any other questions?
Right now, what I understood was that you pop the actions each time they've completed.
Yep.
At the end, when they're all empty, you just fill them up again?
Depends on what it is you're trying to do. So for example, in the game engine, if you're using it for game state management, if the action list is empty, that might be your signaling yourself to quit. So if the only action you have in there is the main menu and you hit quit, it just says, oh, I'm done, and oh, there's no more actions, there's no more reason to run anymore. In other cases, like for a game object, it might just be that he's not doing it, he's just standing there. A lot of your game objects won't have an action list. Like if you have a game object for an object, it's an item, it's not really doing anything. So it's going to be up to what it is you're trying to do. And in certain cases, if you want a continuous action or behavior, you always just have this action that's always at the bottom of the action list that just never removes itself. It always notes that whenever it's unblocked and there's no one else in front of it, then it can create new actions. So you can get repeatable patterns of behavior. The patrol action in the AI example does that, for example. It notices that if it's there by itself and there's nothing else in front of it, then it pushes walk twos in order to make it go around in a path. We had a question over here? Yeah.
So how do you organize, I guess, different classes for like you said actions that contain other actions and stuff like that?
Mm-hmm.
Do you just make another action class that encapsulates that or abstracts that?
Yeah, so the question is, if you have hierarchical actions, how do you organize that kind of code? And the question is that, yeah, you can just have a base action called hierarchical action that always has the base action list in it and the base code for it that you can then derive further if you want to have extra behavior on top of that. So, any other questions? All right, well, thank you.